All right. Good morning.
Good morning.
Good morning.
Okay, that's better. Thank you. All right. We've got the Moodle is down this morning, so I'm just probably going to take roll either at the end of class or wait till tomorrow. So we're going to just go ahead and get started here today with the lesson. Before we get started, does anyone have any questions, comments, concerns? All right.
No.
Just a reminder. A couple of people have asked me to open up quizzes that are closed, and remember your ticket to do that is to go to tutoring on Wednesday. So you go to tutoring, and then you let me know, and then also let me know what quizzes you need open. Okay, and then we'll take care of that. So, okay. All right. Anything else? All right. Well, let's get going. So, I think we're on example 3C on the back side of the guided notes for 3.1. So here we were just talking about function notation and plugging into functions. Okay. And usually this is not difficult for most students. If it asks you, we did to find the value of a function at a variable, that's just asking you to swap out the variables. So instead of here 3x squared minus 2, the f of a would be 3a squared minus 2. So it's just a variable swap. Okay. Now, it gets a little tougher if you have more than one variable. But remember, when we say the value of the function at that, it just means whatever the x is, in place of that, you plug in x plus h. So this would be 3 times x plus h minus 2. Now, often we'll want to simplify this, and so probably the most common mistake made on this is not the function, but actually squaring out the binomial. Remember, you get a trinomial when you square a binomial. So you get x squared plus 2xh plus h squared, and then you can distribute the 3. You can't distribute the 3 until after you've squared out the binomial. So you get 3x squared plus 6xh plus 3h squared minus 2. Okay. Now, once again, if you forget the little pattern there, then you can always FOIL it out. X plus h times x plus h, and just FOIL. Okay. Now, finally, the last example for this is what we call the difference quotient. Okay. Now, and we actually kind of, when we start doing calculus, this is one of the first things that we start with, because this is actually very important in calculus. I mean, it seems kind of weird that, but that is kind of part of a formula. So let's make sure that we can do this. Okay. So this is actually the same for a bunch of problems in calculus. What's different is the actual function. Okay. So here we say the f of x was 3x squared minus 2. The f of x plus h we just did for part 2. So what this is saying, to subtract those two answers divided by h. So it's the f of x plus h, which we did up here in black, minus the original problem, f of x, all divided by h. And so what happens is when you distribute the negative through, the x squareds are going to cancel and the 2's are going to cancel. So because you have 3x squared minus 3x squared and then negative 2 plus 2. All right. Now, if you do it right, then everything left, just these two, will also have an H in it. And why that's significant is because we can factor out an H and cancel it with that H. So we factor out an H and cancel it. And so this stuff up here in parentheses, that's our final answer. All right. Any questions on that? Okay, so I would.
You move
Go
up
ahead.
a little bit.
Yeah,
Move
sure.
to-
Yeah, as a matter of fact, what I'm going to do is I'm going to leave this example up here, and I want you to go ahead and do the practice problem 3C, and do all three parts of it. So this problem, of course, this example is more like the last exam practice problem. Excuse me.
Will you pull up the problems because we don't have the notes?
Okay. Can you get them really quick? Can you ask Miss Buckley to print them off for you? Well, I'll go ahead and put them up there. Okay, so it's the same thing. It's just the function is different. Okay, the f of x. So then I want you to find the f of a, the f of x plus h, and then that same difference quotient, the f of x plus h minus the f of x over h. But it's just the function is different from the example. All right, so Cameron, what's the f of a?
X squared plus 5.
Well, what you do is you just replace
A
the
squared.
x with a, so it's be a squared plus 5. Okay. All right, so Ellie, when you get the second one, let us know.
So is it just x squared plus 2hx plus h squared plus 5?
Yeah, good. So you just FOIL out or multiply out the x plus h squared. So x squared plus 2xh plus h squared, and then just slap the 5 at the end. Good job. All right, any questions on that one? Okay? So then the last one is where you take this answer, the f of x plus h, minus the f of x, the original function, all over h. All right, so Athena, when you've got it.
I got stuck.
Okay. All right. So you start with this right here. Okay. So are you okay on how we got this? Yes. Okay. So then you take this minus that in parentheses. Okay. And then it's all over h. Let's see if I do it on the next page, maybe. Okay. So x squared plus 2xh plus h squared plus 5 minus, and you have to put it in parentheses because you're subtracting off the x squared plus 5. So that's why it's in parentheses. Because otherwise it won't cancel. Okay, all over h. So now when you distribute the negative, you'll get negative x squared minus 5. And then the x squareds will cancel, and then the 5s cancel. Okay, let's see if that's no. Okay. And so then what you're left with is 2xh plus h squared over h. And so now you can factor out an h and then cancel it. And so then your final answer is just 2x plus h. Okay, so it's this part. So this f of x plus h minus the f of x all over h. Then you distribute, cancel, factor, cancel again. So the final answer is 2x plus h. All right. Any questions on that? Okay. All right, next is the idea of what's called the implied domain. The implied domain of a function defined by algebraic expressions is what the input values are allowed. Okay? So if I don't spell out the domain, then you just assume that, well, in general, the domain of a function excludes values that cause either of the following to occur. Number one, zeros in the denominator, or number two, even roots of negative numbers. Okay? So, no zeros in the denominator, no negatives under even roots. See, because you can't have the square root, for example, of a negative, that's where you get your I, the imaginary number. But you can have a negative underneath like a cube root or a fifth root or something. Okay? Anybody need any more time on this screen? So these are the two big ideas. So I kind of write them down like visually here. So this is saying no zeros in the denominator, that's not allowed, and no negatives underneath a radical, and unless the index is odd. and then it's okay. All right. Now, normally, we don't have to really worry about the implied domain. Because, like, for example, if I can plug in anything for x here, then the domain is all real numbers. Or if I just have a list, then the domain is the x value. So 1 and 2, the range would be the output, 1 and 4, the y values. Okay? And so there's nothing really implied about that. We're just told what it is. Okay? But you don't have to be told no zeros in the denominator, no negatives under the radical. Okay? So if I were to ask, come on. Okay? So here, find the domain and the range of the function. Okay? Well, let me just shut up for a second and let you see if you can figure it out. So there's nothing implied about this example. Okay? Because you don't have to worry about zeros in the denominator. You don't have to worry about negatives under the radical. All right, Shannon, what's the domain of this first one?
Zero, -1, -2.
Yes, that's correct. So it's all the x values. Okay? And then what would the range be, Shannon?
Zero, 3, and 5.
0, 3, and 5, all the y values. Okay? All right, so Junior, what about B? What would be the range there? I mean, excuse me, the domain. What's the domain?
I got stuck.
Well, what can you plug in for x? Into that one. Or is there a value you can't plug in for x? Now you can plug in 1, you can plug in 1, you can plug in 2, you can plug in 1,000,000, you can plug in 1,000,000,000. You can plug in anything here because you don't have any denominators, you don't have any radicals, so you can plug in anything for x. So the domain is going to be all real numbers. Okay? Now, the range is all numbers less than or equal to 1,512.49. Now, how in the world would you get that? From the graph. Okay? And so I'm going to show you how to do that, how to find the highest point of the graph. Because see, the y values go from there on down. Okay? So we'll show you how to do that another day. But for right now, what I do want you to know is for the domain, you can plug in anything there for x, because there's no denominator, there's no radical. Okay?
Mr. Strong,
Yes.
are you going to do attendance?
I don't know if you heard what I said, but the Moodle's actually down. So I
Oh.
can't take attendance right now. So I'll either try it again at the end of the period or just take it
Alright.
tomorrow. Okay?
Okay.
So yeah, when you email me and you say, you know, I tried to take that quiz 2.4, but the Moodle was down, I'm gonna believe you because it goes down for me sometimes too. So anyway, so don't stress that. If that ever happens, just let me know and I'll totally work with you. Okay. Let's see, where are we now? Okay, so so the implied domain. So again, this kind of goes back to those symbols that I had. Values that must be excluded from the domain include zeros in the denominator and negatives underneath the radical. So you can write that out in words, or if you want to just write the symbols like I do. So this is, I mean, so okay. So if I want to know the domain there, basically this cannot be negative, whatever x plus 2 is. So what I do is I set the radicand has to be greater than or equal to 0. It can be 0, you can have the square root of 0. But whatever's underneath the radical, you just set that greater than or equal to 0 and then solve that inequality. And so the answer is x is greater than or equal to negative 2. That's the domain. Now, from the graph, the range, and so if you're ever, you can always look at the graph too. The range is the y value. So the y values start here at 0 and then go up. And so that would be the range. Y is greater than or equal to 0. Because the domain is where the x's live, the range is where the y's live. Okay. Let's see. Maybe there's another. Okay. So let's look at this next one. What's the domain of this? Well, I can't have a 0 in the denominator, so x cannot be 5. So the domain would be all real numbers except 5. Okay. And so that's the kind of thing. Now, as far as the range, if you look at the graph, the y values go from negative infinity to 0 and then 0 on up, but they don't actually hit 0. So then the range would be everything except 0. All the y's except 0. Okay. So sometimes you can tell just by looking at it. You can't have a 0 here. Other times it's helpful to actually graph. Okay. All right. So let's see. The other thing that you have to consider when you're doing the domain is what makes sense for the realistic situation. Okay. So like if I said, what's the volume of this bottle? Okay, anybody want to guess? What's the volume of this bottle?
16 fluid ounces.
16 fluid ounces. That's pretty close. It's not exact. But let's say if I were going to accept a range of values, would it make sense if you said negative 3 ounces? No. So in the physical world, in physical situations, it doesn't make sense to have answers be negative, okay? When you're talking about measurements and so on. So that wouldn't be part of the domain either, okay? All right, so go ahead and try those, the practice 4A. Okay, so Avrin, what's the domain of this first one?
I'm confused on how to do it.
Okay, so in the notes, what did I say that, what are the two things you can't have?
Negative in the denominator or not negative, a 0 in the denominator and a negative.
Okay, and so do we have a radical here?
No.
No, so you don't have to worry about that. Do we have a denominator?
Yes.
So what value for x would make that a 0 in the denominator? What value, if you plugged in for x and then subtracted 6 from it, would make that denominator go to 0?
Positive 6.
Positive 6. So that means we're not going to allow you to plug in 6 for x. You can plug in anything else for x you want, but not 6. Because if you plug in 6, that'll give you a 0 in the denominator. Does that make sense? So we would write that as the domain is all real numbers except 6. Okay, now to figure out the range, let's look at the range here. Let's look at the graph. Okay, the y values are everything, everywhere except 0. Because see, the numerator can't be 0. So if the numerator can't be 0, the fraction can't be 0. So the range, we would say, is all y values except 0. The function will never equal 0. All right, let's go to the next one. Okay, so it says the area of a square, the formula is a equals s squared. So what can we plug in for s? What? Go ahead. If somebody knows, just say it. It sounds like somebody's going to say it.
All real numbers.
All real numbers except
0.
Well, you can't have a side of length 0. What else can you not have?
A negative.
You can't have negatives. So you could say all positive real numbers. Okay? Because you can't have negative side lengths. You can't have 0 side lengths. Okay? So all positive real numbers would be what you could plug in. So one way you could write that is you could say the domain is r plus, or you could say x's are greater than 0. And then the y's would have to be greater than 0 too, because you can't have a negative area. Okay. All right. So I don't know if you finished C here, but let's, whoops. So let's try C. Okay, we want to know domain of that. Oh, Brooke. So whenever you've got that.
The domain is x is greater than or equal to 4.
X is greater than or equal to 4. Great job. Because anything less than 4 would give you a negative under there. And so you set whatever the radicand, the stuff underneath the radical, greater than or equal to 0, and then solve it. So the x, the domain, is all real numbers, or all numbers greater than or equal to 4. Now, just looking at the graph here, okay, the y values start here and then go up. So that's how we get y is greater than or equal to 0 for the range. Okay, so what I've tried to kind of show here is that sometimes it is actually easier to calculate the domain and the range from the graph. Okay, so if you ever get stuck and you can't solve that stuff under the radical, or you're not sure what would give you a 0 in the denominator, look at the graph and just see if you can figure out the domain and the range. So the key thing you've got to remember, though, is that the domain is the x's and the range is the y's. Okay? So kind of help you keep that straight. So there, like let's say if I had something like this, all right? Well, I could calculate the domain and range. Let's see, where's the graph? It didn't show up. That's crazy. Okay, so then we would put that in the calculator. Let me just show you how to do that. Uh-oh. Okay. All right, well, so let's just go ahead and try the practice problem. So see if you can put that in your calculator. Put that in the y equals square root of x minus 16. And then figure out the domain and the range just from the graph. All right, so let's look at the graph here first. Whoops. Okay, so the graph is kind of over there. All right, so now if you press graph and you didn't see anything, then try doing something like zoom fit or change the window. See, this is actually shifted over because inside the function, the minus 16 shifts it to the right 16. And so normally your standard viewing window only goes to 10. So you would have to change your window so that maybe from the x max being 10 to 20 or something like that. Okay? So any other problems getting the graph? Let's make sure that we're okay with that. Okay, everybody okay with the graph? Okay, so now let's figure out the domain and range from the graph. So let's go with Dominic. So what's the domain based on the graph?
X is greater than or less than 16.
Well, it can't be greater than or less than. You mean greater than or equal to? You mean greater than or equal to?
Yes.
Okay. All right. That's exactly right. Because it can be equal to 16. So from 16 over, that's the domain. All right. And so what's the range, Dominic? What are the y values?
Y is greater than or equal to 0.
Yes. Great job. Great job. So see, the x values are from 16 over. The y values are from 0 up. So excellent, excellent work. Okay. Any questions on that?
Yeah, how do you figure out the range?
Okay, so the range is the y values. So you say, okay, where did the y values go? Well, for this one, they start right here and then they go up forever. Okay? It's kind of slow, but it does. It goes up forever. It's a little more curved than that. But anyway, so we say it starts here at y equals 0. So this is y equals 0 and then goes all the way up forever to infinity. So y is greater than or equal to 0, or you can actually say from 0 to, well, actually a bracket here, 0 to infinity, like that too.
So do you have to graph it?
No, I'm just trying to get you practice so that if you have to graph it, or if you get stuck some other way, then you can graph it and still get the right answer.
Okay.
That's my whole goal for this problem. But no, you wouldn't have to graph it if you can. After you had enough experience, you could just look at it and tell. Okay? All right, great job. All right, and so that's it for 3-1. So now we're going to go on to 3-2. Maybe. Okay, so this next section is about linear and quadratic functions. These are usually the first ones that you learn to graph. Okay, graphing lines and graphing parabolas. So again, I think most of this section will be a review. Okay, so linear functions and their graphs, so that's going to be lines. Quadratic functions and their graphs, the parabolas, and then maximum and minimization problems and maximums of graphs. So like when I said that I was going to teach you how to find that max point on that one problem, so that's going to be in this section right here. Okay. All right, so it says a linear function is any function that can be written in the form f of x equals mx plus b or y equals mx plus b. M, remember, is the slope and b is the y-intercept. Now, if I have like a function equals a constant, like y equals 3, that's still considered a line. Just you have a slope of 0 there. So a horizontal line, y equals 0, y equals 3. And then if I have x equals a, like say x equals 4, that's still considered a line. It's a vertical line. Okay? But those are the different types of lines. So we have horizontal lines, vertical lines, and then any line that has a slope that will be able to be written in the form y equals mx plus b. Okay? All right. So in this example, if let's say we want to graph f of x equals 3x plus 5. Well, we've already learned 4 different ways to graph that. Before we didn't have it in function notation, but if it's y equals, you graph it the same way. So the way I would do it is with the slope-intercept. So I would go to graph the y-intercept at 5. So 1, 2, 3, 4, 5. And then the slope is 3. So I go up 3 and over 1. But now since that's off the graph, then you can go down 3 and left 1. It's like negative 3 over negative 1. And so then you have your line. Okay? Now, if you have no slope, like in this example, f of x equals negative 2, so that's just like y equals negative 2, so that you go down to negative 2 and draw your horizontal line. So I know we've graphed these before. It's just before they had y equals. And I'm just trying to say it's the same thing when it's f of x equals. It's just in function notation there. Okay? All right, so go ahead and do practice 1, please.
Is g of x considered x or y?
Say that again, please.
Is
g of
g
x?
of x considered x or y?
It's
or...
still a y. Because it doesn't matter if it's f of x, g of x, h of x. It's just like the y. Okay? Great question. Okay? So let's just kind of have you self-check your answers here. So the first one, your y-intercept is 2, and then from there you go up 3 and over 1. Okay? And then the second one, g of x equals, oh wait, does yours say negative 3 or positive 3? Let's see.
Negative, or positive, I mean.
Oh, it's positive 3. So that should be up here then. Okay? All right, any questions on either of those graphs? Now, when any of the ones that we're doing in this section, if you ever get stuck, you can just check it with your graphing calculator. Okay? So it's just, you just press the y equals button instead of f of x, and you just graph it. Okay? All right, part 2, quadratic functions and their graphs. A quadratic function is a polynomial function of degree 2. So it is any function that can be written in the form f of x equals ax squared plus bx plus c. So what makes it quadratic is the exponent, is 2. So the simplest quadratic is just f of x equals x squared, and that basic graph is a parabola. Okay? So the graph of a quadratic function is a special U-shaped curve called a parabola. If the leading coefficient of a quadratic function is positive, the graph of the function opens up, and the vertex of the parabola is the minimum point. on the graph. So this vertex here is the minimum value if the parabola opens up. If the leading coefficient of a quadratic function is negative, the graph of the function opens down, and the vertex of the parabola, that the turnaround point, is the maximum point on the graph. So it may seem weird that we do the same thing to find a maximum or a minimum, but in each case, we're actually finding the vertex of the parabola. All right, so one of the things that helps us graph the parabola is its symmetry. Every parabola is symmetric to what we call its axis of symmetry. So the axis goes through the vertex, and one side is a mirror image of the other. So if you find a point over here, you've also found a point over here because of symmetry. Okay, now, so here, this is, we're going to do some practice, and we're probably not going to get through all of this here today, but we're going to work with what's called the vertex form of a quadratic. And that is one way where we can easily find the vertex. I'm going to actually show you 3 different ways to find the vertex of a parabola. So one way will be this vertex form. Okay? Now, if this number is the number in front, okay, we said if it's positive, it opens up, and if it's negative, it opens down. Okay? Also, there's something else that this number in front, the a value, tells us. If the absolute value of a is greater than 1, then that means the parabola is going to be narrower because it's going to shoot up quicker. So like if you have a 3x squared, it's going to shoot up 3 times faster. So it's going to be narrower. And then if the absolute value of a is less than 1, it's going to be wider because it's going to go up slower. So like if I have y equals 1/2 x squared, then it's going to be wider than y equals x squared. And then if a equals 1, then it has the same width as y equals x squared. Okay? So we'll be able to tell a lot about the parabola just from looking at the equation. Before we even graph, we'll be able to tell, does it open up or down? Is it wider, narrower, the same width as y equals x squared? We'll also look and we'll find the vertex. Because really the vertex is, for most of the time, the vertex is the only point I expect you to get absolutely right. Okay, exactly right. So what's the point you have to have exactly right?
Vertex.
The vertex. Okay, so that's why I'm going to teach you 3 different ways to find the vertex. Okay. All right. So now this problem is already written in vertex form. Okay. So let's go back and let's talk about what vertex form is. So when you have y equals a times x minus h squared plus k, then the vertex is the point hk. So you take the opposite of the number inside the parentheses with the x, and then you just take the number on the outside for the k. All right? So just looking at this, the vertex is the opposite of -4 is +4 and then 3. Okay? All right? So the vertex is 4, 3. Everybody cool with that? All right, next. because the number in front, the a term, is negative, that means the parabola opens down. Okay? And then because of the 2, it's going to open narrower. Because that number, it's bigger than 1. Okay? So it's narrower than y equals x squared. Okay. So, so what this does, when we can get the vertex, see, this is like the y equals x squared, except we're shifting to the right 4 and up 3. That's where the vertex is. And then the negative makes it go down, and the 2 makes it narrower. Okay? All right, so just looking at that example, okay? So it says, describe how each part of this graph compares to y equals x squared. Then I want you to graph it. Now, you can always use your calculator again if you get stuck, but I don't really expect you to use your calculator on this, because you can kind of do it all by hand. But if you ever get stuck, use your calculator. All right, so let me give you a minute to see if you can write down the answers to this, and then we'll start going over. If we don't finish, then I want you to finish it for tomorrow. All right, so Brooke, what does the negative do here? The negative in front.
The negative makes it open down.
It opens down. Okay, opens down. All right, Alana, how about the 1/2? What does that do to the graph?
Makes it wide.
Yes, excellent. It's wider than y equals x squared. All right, Rachel, what does the x minus 3 do?
Moves it to the right 3.
That's exactly right. So right 3. Okay. Oh, let's see, we're running out of time here. I don't know if we can get through it. All right, Cameron, what does the square do to the parabola? Oops, I just said it. What does the square do to the graph?
It turns into a parabola.
It makes it a parabola. Okay, it's a quadratic. Okay, sorry about stealing your thunder. Okay, so how about tell me what does the +4 do then, Cameron?